So in this video, we're going to be looking at getting a design model ready for assembly and also how to get it ready for inserting components on the inside. So let's jump into Fusion and give it a go. So hopefully by now you should be up to this stage with your model. So in your browser, you should have this body created. And so at the minute, I no longer need this canvas because it's just sort of extra. So by now, you should hopefully be up to this stage where we've got just this one body in our browser. So this is just like the base of our design. So for this next stage, I no longer need this canvas. So what I'm going to do is go to the browser and click the Show Hide button on canvases. This just gives us a bit more visibility for this model. So what I'm going to show you now is how to hollow out the inside of this component. So if you go to the Modify menu and select Shell, it'll ask you to select either faces or bodies. So if I select just this front face and type in a wall thickness of 2 mm, what it's going to do is it's going to remove this face that we select and wall thickness all the other sides instead. But I still need this front face. So the way to get around this is if I just click Cancel. So if you go to the Select drop-down menu and then go to Selection Filters, just make sure that Select Through is ticked, because that'll just make the next step a lot easier. So again, go back to Shell, and what you can then do is left-click and drag this rectangle around all those faces. So it'll now select all of them at once. I can then type in a wall thickness, so I am going to go with 5 mm and simply click OK. So at the minute, this is going to look like it hasn't made any difference. So the way you can actually observe this difference is if you go to Inspect and then Section Analysis near the bottom. Then select a face to start your analysis from. So I'm just going to select this front one. And then you can just click and drag this arrow. So as you can see from those hatchings, I have got that wall thickness there of 5 mm. I'm happy with how that looks, so I'm just going to click OK. Now, this is the point where students are going to absolutely hit the roof. Because from looking at this, it looks like our model has been chopped in half. It hasn't, it just has the appearance of that. So the way to work around this is to find the analysis section in your browser and simply click Show Hide. And it'll now show us how it actually is as a model. So the next stage is another key point in OCR's criteria for the Level 2 course, and that's Design for Manufacturing and Assembly. So in order to hit this criteria, what we need to do is prepare our CAD models so that they have some information and some consideration for actually taking this apart and assembling it. So to do this, I would create a offset plane from the construct plane. And I'm going to select this front face. This is just where we're starting this plane off from. So if I look at it from above, I'm just going to drag this back. So I'm going to do it by minus, I'm just going to go with -1 for now. And that's not big enough, but it just helps me show you a common mistake that students might make. So I'm going to do this by -1 and I'm going to click OK. And it should add that offset plane there. So at the minute, I've got this offset plane, but now what I'm going to do is split this body by using this offset plane. So I'm going to go to Modify, select Split Body, and it's going to ask me the body to split. So that is this one, Splitting Tool. So where do we want those big giant scissors to actually cut this? So I'm going to click that, and then we're going to select the offset plane. And it'll give you this big red circle, just showing you where it's going to cut. So I'm happy with that for the time being. So I'm just going to click OK. So now when I look in my browser, I'm going to hide that offset plane by clicking on Construct. And in my bodies menu, if I just expand this folder, I've now got two bodies. So I've got this lid section and this main body. So if I hide this lid section, you can see that it's not quite cut into the model fully. Now that's because that offset plane isn't far back enough to actually cut through this wall. So I could either change that wall thickness by editing the shell, or I can do it by doing the offset plane. So because that was only a 1 mm offset plane, that's what I'm going to do. So I'm going to right click on that offset plane on my timeline, and I'm going to select edit feature. This just takes you back into this window and lets you change it. So rather than -1, I'm going to go with, let's say, -7, and then I'm going to click OK. So now what it does is it recalculates everything after that on the timeline, and then it redoes all that model so that it edits those changes. So if I now click the eye on body 2, I can still see that it's got this lid section, but now it's actually made it so that it cuts within that wall thickness. So this is exactly what we want to happen. So before I start adding too many bodies, what I'm going to do is start to organize my files within this browser. So to do that, left click on it and then double click, and you can rename that file. So I'm just going to call this one main body and then press enter. Double click again, and I'm just going to call this the lid section. Type it in and press enter once again. So I try and do this quite early on, and I'd encourage students to do the same, just because later on when you're trying to rework and assemble different sections, it just makes it that little bit easier to find them. So now that we've got these two separate sections and this hollowed out interior, what we're going to do is we're going to start creating some of these buttons that go on the front of this design. So I've got those buttons on my canvas, so I'm just going to click show on the browser again. And what I'm going to do for this is I'm going to create a sketch on that front face of the model. Once in here, you can then use the options from the create panel to do whatever buttons those are. So I'm going to do the power button in the middle by using a 2-point rectangle. So I'm simply just going to left click, drag the mouse out and left click again. Again, on these, the dimensions, rather than using those decimal places, I'm just going to round those either up or down, just so I've got easier values to work with. So now that I've got this power button, I'm also going to add a volume button. So I'm going to use the 2-point circle to do this. So click once, type in your value and press enter. So because this is a hand-drawn sketch, it's not going to be completely accurate. So what I'd suggest doing is, because these buttons are symmetrical, I would then use the line function from the create panel, and I would just draw a line that cuts through the center of this rectangle. So to do this, if you zoom in, you'll notice that when you go to the middle of this horizontal line, it comes up with this triangle on the cursor. That's just showing that it's being placed on the midpoint of that line. So I'm going to left click there, go down to the bottom, and make sure that that is at 90 degrees, and then click again. So you'll notice that it's added these two midpoint constraints. So that's exactly what we need to do this. So I'm not going to sketch around all those buttons because the rest of them are pretty self-explanatory, but I'm going to use this mirror function. So I'm going to select mirror. I'm going to select this circle as my object, and then I'm going to go to mirror line and select that center line that we created before. So you'll notice that that second one is a bit off from our hand-drawn sketch, but this is actually more accurate. So I'm just going to click OK. Then I'm just going to delete that mirror line by clicking on it and pressing delete on the keyboard. Now I'm going to finish that sketch, and I've now got these sketches ready to extrude. So I'm going to go to create, select extrude, and it's going to ask me for the profiles to extrude. So I'm just going to go with this rectangular one first. I'm going to extrude those out by 2 millimeters. So I'm just going to type in 2. But you'll notice in the dialog box, the operation changes to join automatically. So what it's wanting to do is create this button and join it as one body to this lid section. We don't want that. What we want to do is change it from join to new component. So the difference between bodies and components is that bodies are just recognized as a mass of material, whereas components are viewed by Fusion as an actual working part. So because these buttons are later on going to move, we're going to select a new component and click OK. So you'll notice that it now, rather than being within the bodies folder, it's got its own section. So again, I'm going to click and then double click. I'm just going to name this power button. So that is our component there. So next, you'll see that I want to extrude the sketches that are made for these buttons. But what Fusion will do, just to keep your workflow going, is once you've used a sketch for a feature such as an extrude, it will then hide that sketch just because it assumes that you're done with it. So all you need to do is go into your sketches folder in your browser and expand that folder out, and just click on the show button for the sketch that you need. Once you've done this, that sketch will then stay until you then click this button again. So I'm just going to click on extrude and I'm going to repeat the process again. So I want a 2mm extrusion, but I need it to be a new component. So I'm going to do the same again, extrude, 2mm, and change it to new component and click OK. So for now, I'm going to hide that sketch because I'm now done with it. And I'm also going to hide that canvas as well. So now I've got these 3 buttons on the front, which I'm just going to quickly name. So I'm just going to call that minus volume. And then, of course, this one is just going to be the plus volume. So now what I need to do is, now that I've got these as their own components, I need to add some sort of motion relationship between these components and some existing ones. So in order to do this, I need these buttons to move in and out around this lid section. So at the minute, this lid section is just the body. So I need that to be a component instead. So I'm going to left click on that in the browser. I'm going to select create component from bodies. So I don't need to rename this because it'll just keep that original name. It will just make it a component instead. And I'm just going to do the same again on the main body. So now I've got these all as working, functioning components instead. So what we're going to do now is add that motion relationship. So to do this, go to the Assemble drop-down menu and select As Built Joint. So what this does is it's telling us that we've got 2 components that are already in the position they need to be. We just need to add some sort of motion relationship between them. So I'm going to start off with this circular button in the top right. So when you're selecting these 2 components, always select the component that's going to move first and then the other component second. So I'm going to select the button and then the lid. So underneath motion, it'll give you a range of different motion types and it'll tell you what they are if you hover over them. So I'm just going to need a slider. So now it's going to ask me to select a snap. This just means where is that motion originating from. So if I just zoom into this button, what I need this motion to start with is at the top and the center of this button. Now, this button's relatively easy because it's only got that one place on the face that it can attach it to. But later on, when you get to a point where you've got more faces, it becomes a bit more difficult. So to do this, you can just left click on that center point, or if it's a circular component, you can also select the edge and it will place the origin in the center of that circle. So I'm just going to click on that edge and you'll notice that it animates that motion. So from here, what you can do is you can decide whether that's sliding along the right axis or not. So at the minute, this is, so I'm just going to click OK. Now, for those keen-eyed viewers, you might have noticed that this joint was moving in and out of the model. That's obviously not correct. So what you can do is you can go to your timeline at the bottom, and if you right click on that joint, you can then do edit joint limits. So what this does, it tells us a maximum and a minimum point where that motion can move to, and it also allows us to set a rest point. So where will it automatically return to once that motion is finished? So for this, I'm going to set a minimum, and if you look at the direction of this arrow, it's moving out to the right along that z-axis. So my minimum is actually going to be a negative value. So I'm going to go with negative 1.5. And again, you can use animate to watch that motion. So I now need to set a maximum, which I'm just going to leave at 0. And I'm also going to set a rest point just so it returns back to that starting position. And then click OK. So for this video, I'm not going to do this other button because it'll just be the same again. But I am going to do it on this rectangular button here. So again, go to Assemble, As Built Joint, and I'm going to select those two components. So again, the component that's moving first, and then the other component second. So now again, it's asking me to attach this snap point. So what you'll notice on the rectangle is that there's more than one snap point. So let's say I wanted this middle section. Every time I then go to select someone else, you'll notice that it's trying to snap to loads of different points. So if I go on this face and it turns a pale grey, what I can do is hold Control on the keyboard. And what that does is no matter where I put that cursor, it's locked in to only the origin points on that face. So I'm going to use that now, and I'm going to select that middle one. Once again, you can change your axis if it doesn't look right. So this does, so I'm just going to click OK. Then I'm just going to repeat that same process again, but this time I'm going to go to the joint from the browser. So I'm going to expand that joints folder. I'm going to go to slider 2, and I'm just going to left click on this edit joints icon. So once again, it's the same values. It's a minimum of minus 1.5, and then maximum and minimum are just going to be set as 0. And I'm going to click OK. So those joints are now added. So again, that's some of the criteria for OCR ticked off in terms of designing this to actually assemble and function as a working model. So next, what I'm going to do is I'm going to start looking at inserting some of these internal components to make this function. So first of all, I'm just going to hide some of the features that I don't want. So I'm going to hide all these buttons and also the lid section, just so I can see inside of this component. So what I'm going to do is I'm going to need to save this design first. Then what I'm going to do is I'm going to go into the data panel. So I'm going to click this icon in the top left. Then what I'm going to do is I'm going to look through my file storage, and I'm going to find the files that I need. So for this one, I've put it in the project already, and I'm just going to need this speaker assembly. So what I'm going to do is right click on that, and I'm going to do insert into current design. So what it now does, if I close this data panel, is it inserts this into our current design workspace, and it allows us to move it about and see where we want to place it. So you can use these arrows to slide it along an axis, or you can use these rectangles and move it around a bit more freely. So I'm just going to move it just so it's out the way of this other section here. And then I'm just going to click OK. So those components are now inserted into this design. But one of the things that I definitely recommend doing first is if you look in the browser, it's got this chain link symbol. Now what this means is that file that we've just inserted is still attached to that other master file that is in our data panel. So if I was to then open up this master file in another window and change that, it means it would be linked to this one and that would automatically change as well. So last year, one of our level 2 engineers accidentally opened up that master file and he doubled the size of those speakers. So everyone in the entire project suddenly had these massive speakers sticking out of their designs. So the first thing that I'd get students to do is right click on whatever component it is that you've added in and select break link. So these components now stay within this design workspace, but they're just no longer attached to that master file. So another thing that you may have noticed is the symbol for this component is slightly different than the previous ones that we've got. So you'll notice that it's 3 cubes stacked. So what this means, if I expand that folder, is that it is a component made up of subcomponents. So these are all their own components that make up this entire one. So I have got my PCB board, 2 speakers, and this 9-volt battery. So the first thing that I'm going to do is I want all of these smaller subcomponents on my PCB board to actually be attached to the PCB board. So I could do this by creating loads of separate as-built joints, but there's a much more efficient way of doing this. So this way is to go to Assemble, and you can go to Rigid Group. So this just means it locks all those separate components together. You can then select whether you want to include child components. So these are just those smaller subcomponents. So I'm just going to leave that ticked. And all I've got to do is click on all these components. Make sure they're all selected. And then simply click OK. So now if I go to Move Copy from the Modify menu, change this and make sure it's on Components. If I now move this, it moves as an entire entity rather than just one. If you are doing this, make sure you click Capture Position before you press OK, just so it remembers that you have moved that component. So I'm going to move this so that it's in line with the back of this section here. And I'm also going to use these dials. So if you click and drag, you can then rotate this by a chosen value. So again, capture position and click OK. So what I now want to do is make some sort of housing or backing for this PCB board to stand on. So the way I'd recommend doing this is if you go to Create Sketch, and I want to create this sketch on this inside face here. So now what I want to do is make the standings for this. So rather than actually sketching all these separate elements myself and making sure they're in the correct position, there's a quick and easy way to do this. And that's to go to Create, Project, Include, and select Project. So this just traces around a feature and adds it to the sketch panel that you're already on. So if I look at this from a slightly more diagonal, so this nice isometric view, I can either do this as specified entities such as edges, faces, but what I'm going to do is select bodies instead. And all I have to do is click on this PCB board and you'll notice this purple sketch appears here. So that's just projecting that body onto that sketch that we've created. So I'm going to click OK, then Finish Sketch in the top right. And then what I need to do is extrude these circles in the corner out. So I'm going to select Extrude. I'm going to zoom in and orbit around slightly, just so I can see these that bit better. I'm just going to click on each one of these. And I'm going to extrude them out by, let's say, 5 millimeters. So I'm going to leave it as join just for now and click OK. And so that has now entered this main body. So I can now see that it's joined the body that it was touching in there. So the next step is to actually join this PCB board to these standings and these fixtures. So to do this, we're going to go to Assemble, but this time we need to select Joint. So this is when we're connecting two components that aren't already in the position. So it's going to ask me to select my first component and then the second component. So once again, I need to select the component that moves. So in this case, I want to move this PCB board over to this backend. So if you zoom in, I want this joint origin to be on this circle. So you might need to do a bit more zooming in if you're on a bit of a fiddly mouse. But once again, if you remember to hold Control on your keyboard, you can lock into that face. So I'm just going to select the center of this top left one. And then it's asking me to select the origin for this next one. So I'm going to zoom in again, and I'm going to select this top face here. So it'll move in place. So then, because this is just a normal joint, I can then have a little play around with it by using these arrows. So I'm just going to set that as -2, just so it's fully on to that fixture. Move my little floating head, and then I'm just going to simply go to motion, and I'm going to set this as rigid because I want it to stay in this position, and I'm going to click OK. So you'll notice that again, it's moved the entire PCB board because of that rigid group that we've already set up. So in order to do the rest of the components, you'd simply do the same again. You'd project a sketch and make a housing for those components, and then you'd use the joint option from the assemble menu just to connect those. So I'm just going to skip past that section now, and I'm just going to move on to actually inserting that lid section. So now that we've got those components jointed and all of our internals sorted, what we're going to do is start to add an actual connection for this lid section. So if I just show that lid section again, so on our design, it looks like it's connected, but in terms of design for manufacturing and assembly, there's nothing actually there functional wise to show us that we can separate that section. So that's what we're going to try and look at now. So to do this, I'm going to go to create, and I'm going to create a sketch on the front face of this lid. So the reason why I'm creating this sketch is to actually just plot out where we're going to put those holes. So to do this, I'm going to first add a 2-point rectangle, and I'm going to lock it in to this top left section here. Drag it down, and then again, wait till the cursor changes and locks into this bottom section. Then what I want to have is a rectangle just inside this one. So to do that, you need to go to Modify and Offset. So make sure that that offset window is open. So what it's asking us to do is select what sketch elements do we want to create an offset of. So that's just of the rectangle we've just created. So then you can drag this in and out, or if you want to flip which side it's on, just click the symbol next to flip. So I just want this to be, let's say 1.5 millimeters on the inside, and then click OK. So now that we've got this sketch, we want to actually create points at the edges of this rectangle. So to do this, go to Create and select Point. This just literally, imagine it's putting a little dot just as a reference point. So if I zoom right in, again, it's going to change our cursor to show that it's on the edge of that rectangle. So I'm just going to make sure I select all those dots when that cursor changes. So it's for this internal rectangle, not the outside one. So once I've done that, I'm going to click Escape, and then I'm going to click Finish Sketch. So what you can do now is see that we've got this these 4 points on the edge of this rectangle. So now we're going to actually create the holes using those reference points. So go to create, select hole, and it's going to give us a big list of options. So the first thing it's wanting us to do is pick a face to put it on or some sketch points. So we're just going to select that sketch point that we created before, and we're going to select all 4 of them just by left clicking on each of those points. So you'll notice that that diameter is obviously much too large because it's cutting out too far. So what I'm going to do is I'm going to first select my hole type. So I want that just to be a simple hole, but I can also select the tap type. So simple, clearance, tapered one, but I'm just going to select tapped. So I want to have that thread in there as well. And then you can change your drill point. So I'm just going to go for flat. And if you scroll down in this menu, you can see that it gives you a designation. So I can actually select what screw I want. And this just makes it easier in terms of looking at standard components. So what I'm going to look for is size. And I'm just going to select 2mm. And I'm just going to zoom in and just see how that looks on the model. So that looks fine to me. It's not cutting through the edge. It's not missing too much off. And it's a good screw size as well. So what I'm then going to look at is if I use the view cube and look at this from the top, I can see how far it's going in. So I can also change the depth of that by using this panel just here. So what you want that to do is to cut through the lid and also enough of that main body in order to give it enough grip. So I'm just going to set that as 15. So I think that's enough. So I'm just going to leave that at 15. And what you can do now is make sure that modeled is ticked. And that just means it actually puts that into your CAD design rather than just doing it as a graphic. So I'm going to remember these values. So I'm looking for an M2 screw with a 15mm depth. So I'm going to click OK there. And you'll see that it's now added those screws there. And if you were to zoom right in, you'd also see those threads as well. So what I'm going to do now is, you might have guessed, is to actually insert some screws into those threads. So rather than CAD designing my own screws, which would take a while, I'm just going to use some that are already there. And again, OCR really likes it when you do this because it's showing that you're having a bit more efficiency in your design. And it also, if the students evidence the fact that the customer could then replace these screws easily if they are a standard component. So to do this, go to Insert and select Insert MacMaster Car Component. Bit of a tongue twister, but that's the one we're looking for. Click OK. And what it's going to do is it's going to bring up this database full of all different types of components. There's all sorts. You could spend an entire day looking through these, but I'm just going to need screws and bolts. So along the left, it's going to give me some different dimensions and some geometries to select from. So because we're working in millimeters, we need metric. And it then changes these, so the thread type. If you remember, I needed an M2. And then it gives us our length here. So it tells you in these diagrams what this length actually accounts for. So I need this to be 15mm. So I'm just going to click that. And also gives you different ones like your thread pinch, your head type, little things like that. So what I'm going to do now is it's giving me a list of options that fit that criteria. So it's giving me a fully threaded stainless steel socket head. I'm completely fine with that. So I'm going to click that and it'll give me this little box here giving us some product details, and it allows you to download it as a CAD file. So I'm going to select that drop down menu and I'm going to download it as a 3D step file. Change to that and just click download. Now, if you give it a couple of seconds, it should just download that screw or whatever component it is straight into your workspace. So again, it's going to allow us to select where we want to place this component. So I'm just going to move it out the way of that other body and click capture position and then OK. So again, we're going to use that same skill that we used before. We're going to go to assemble, select joint, and we're going to need to select our two components and our joint origins. So the first joint origin we're going to need is on the component because that's the one that's going to be moving. And we're going to need to select the center of this face here. So again, you might need to zoom right in for this, but if you hover over that face and keep hold of control, you can then select that center point. Then it's asking us to select component 2. So I'm just going to click on home. And we want to select this lid, but we want to select the center of this thread. So again, keep hold of control on your keyboard and then select that center point there. And you'll notice that it locks that component straight to it. Sometimes though, it might insert it the opposite way around. All you have to do is click flip and just make sure that that's in the direction that you need it to be. So I'm going to go to motion, and again, list of options here, and what we're going to be going for is cylindrical, because we want this screw to move in and out of that hole as well as rotating. So I'm just going to click OK there, and then I'm going to right click on the timeline and edit those joint limits. So it's going to give us two options in this window. It's going to give us a rotate and slide. We want this to be able to rotate a full 360, so we don't need to put a limit on that one. But we do need to limit how much it slides. So again, we're going to set a minimum and a maximum and a rest position. So sometimes the arrow's a bit difficult to see. So if you just type in a value, so that's moving in that direction. So we don't want it to move there. So I'm going to leave my minimum as 0 and set my maximum as 15, because that's the depth of that screw. You can go just above or just below if you like, but I like to leave it there. So our rest position should be at 0. So if I click here, it's going to animate that movement. So that's exactly what we need. So I'm just going to click OK. Then all you'd have to do is that same process again until you've got all 4 bolts in there. So we're just going to leave this video here for today, and we've been through quite a lot of skills there in terms of assembling that, but the main ones to consider are splitting that body, creating joints with different motion relationships, and also inserting some of those standard components just for DFMA. So thank you and see you in the next video.